All right, our last session for the day today will be what I would call a meeting of the minds in the world of remote execution API development. The topic is Remote Execution API version 3, and we've got core team members that have been leading and contributing to the development of remote APIs over the past several years. So I'd like to welcome George Genscher, Jörg, Steven Bergseeker, who is a new face for today from Google, and Paul Adams.
Sweet.
Guest appearance by Ed, but it's very late in Europe.
He's sleepy, that's fine.
All right, take it away.
Okay, so real quick, can we get my shared screen on? I don't know how to do that. There we go, perfect. So yeah, just as Helen said, we are Ulf, Steven, me, and Jörg. If you haven't seen any of us before, it's because you've been siloed under one of our products and just haven't seen any of the others. We have all, for the most part, been working roughly together for the past 4 years, maybe a little bit more, actually. Yeah, 2017 tops. On remote execution, you sort of know most of the story of how a lot of those things went. I volunteered to participate in the remote APIs working group, which is a meeting that we all, for the most part, attend regularly, and then also volunteered to do the original open source implementation of remote APIs that probably didn't predate the start of work on RBE, but definitely predated the release of it. And we acted as a nice information source for most of the other implementations that have come out since then for remote execution. And I maintain that the community that we put together is pretty cohesive. We're all sort of egalitarian for the most part. Even the remote APIs repo is separate from Bazel, doesn't sort of fall under the same guise and rules. But I will jump to our next slide, which is sort of the rough agenda for this panel. This is the first time Ulf has seen it, and maybe even Jörg, but I gave Steven a heads up on this. It's worthwhile to have a minor history of this remote time, at least as far as this API is concerned. So the first revision of this that came out in 2017, I'm pretty sure, was called V1 Test, had a number of unique details associated with our work, had a great flowchart and a bunch of helpful advice from the Googlers and from the soon-to-be RBE team about how these things are going to how software should be written, and I have to thank them actually immensely. I don't know if I ever really did this. I wouldn't have been able to correctly implement build farm, or at least a lot of the details associated with it, if it weren't for Steven's help, Ola's help. At the time, I'm sure Helen was involved with that, and Eric Burnett. So those guys were all really helpful, and then I tried to pay it forward and send on some assistance to the build grid team and the build barn team, being a reference for them. That takes us through to more or less a V2 that came out, I want to say 2 years ago, possibly 3 years ago. That V2 transitioned from a test to a V2, but the major backwards incompatibilities were, I wouldn't say that there was a whole lot of backwards incompatibility. I don't know, somebody else to chime in. This isn't my talk, or at least it's not just my talk.
I would say it was conceptually very similar, although we opted for an increased reliance on what we hoped would be good standardized technologies like ByteStream and the Watcher API. In retrospect, maybe not the best choice, but I don't think there were a lot of conceptual disconnects between V1 test and V2. It was just a lot of cleanup and some more trying to standardize on certain key pieces.
Right. So we dropped a couple interfaces. We added a few. We've gone through a couple of new revisions, like V2.1, which added, if I remember correctly, the compression URL or the compression resource encoding to ByteStream, and there were another couple of changes associated with output paths. So that brings us more or less to what a V3 cut, which doesn't exist yet. We have a stack of issues and a stack of ideas that have been discussed at previous meetings, but what that would mean, aside from possible backwards incompatibility. I added our possible goals that I recorded from the last couple of sessions that we've had where I've brought up this and begged people to tell me what they want. We have fix all the weird things. There are a number of odd interfaces that exist. There's some details associated with the resource in ByteStream that says you can append whatever the hell you want to this resource name, and you're supposed to be able to parse it. Mine doesn't. I don't know if anybody else's does, but I would look forward to anyone writing the acid test that proves that any of us aren't really adhering to the spec. Let's see what else. We could drop some of these redundant interfaces. We could move all of the activity for ByteStream into the content addressable storage interface, for instance. This is a radical idea, to say the least, but maybe maybe anyone else has thoughts on pulling those redundant ideas out. We could standardize outputs, and that actually means a bunch of different things. We could change some of the behaviors associated with execution so that we know we want different reactions from clients, or that we want to expect different things. And then the other sort of semantic meaning on that outputs is we've got output files, output paths, output DIRs, and a whole bunch of other deprecated things. This could go into fix all the weird things, but that would be one possibility for a V3. And then there's, do we want it to just be the introduction of new interfaces? I selfishly always put up my action graph idea and say that if we don't get an action graph protocol at some point, it's fine by me. I'll just go ahead and do my own inference engine that figures out the action graph and does predictive execution. So tell me your thoughts.
So well, my first thought is there are a couple areas that aren't mentioned here, which might be interesting. So one thing that we discussed very heavily at the beginning was the number of round trips in order to run an action or in order to get a cache hit. And the current protocol is not optimal. Maybe Steven will grow and disagree with me and everything. So Philip Wallerman and Jacob Buchgraber had some interesting ideas at the beginning of how to minimize the number of round trips. And what we've seen in our deployments from EngFlow is that in some cases people have very high latency to the next data center, right? Sometimes people live in areas where there aren't any nearby data centers right now. I'm just thinking of Israel, where I believe currently all of the 3 big cloud providers are building data centers in Israel, but right now they have to go to Zurich or other places. And that just is a fairly high network round trip time, and that's causing performance issues. When you do builds locally, it's not as much a problem for CI, where typically the CI system would be co-located with remote execution, but it is a problem for individual developers. So that's just one area that we could be talking about for V3 or not. Getting rid of all of the round trips is not straightforward, and the protocol that Philip and Jacob came up with is somewhat unusual. Let me put it like that. And that caused a lot of interesting discussions on the team. And eventually, the decision not to go with that, but to go with a more traditional protocol, even if it might not be theoretically quite as efficient.
So, Ulf, can I jump in for a minute?
Yes, go for it.
Because I do recall those discussions way back in, goodness, 2018 probably. I think my memory is that the data at that point were not compelling enough to make us make such a large departure from where we already were. I think if there's good data that says, hey, here's what the impact could be, or is for this prototype, then that could be a motivating use case for V3. I think that kind of touches on what I do think should be a requirement for V3 is really solid prototyping. We made V1 and it basically worked and got some things wrong. And then we made V2 and we fixed some of those things and it basically worked and we got some other things wrong. I'm sure that when we make V3, we will get some things wrong. I have yet to meet a perfect API. And I think the more we can do our homework ahead of time and do some prototyping and make sure that we're making good decisions, the better. So, I think I welcome data from any sort of prototype or live system that could tell us, hey, if we switch to a bidirectional streaming model for execute calls, or whatever it is we want to look for, that could be something that motivates a major disconnect from where we are in V2.
Absolutely, I'm not pushing for that right now. I mean, if I look at Bazel, which is the implementation I know best, even today it's not nearly using the current protocol optimally, or even close to optimally. I threw out a patch late last year because I found that Bazel was asking for every input for every action, and so if you have a lot of actions with duplicate inputs, like the C++ compiler or the Java runtime, Bazel is very chatty, and even just from me to another, I live in Europe, I live near Munich, and so from Munich to London is not that far away, but even just that distance already caused significant performance issues without the patch. So after fixing Bazel not to do that, it got a lot better. And that was we also had tested that in a couple other scenarios, and we got similar results. But yeah, back to the API. What other things were there? I know Ed had a number of proposals, some of which are already in the REAPI repository. The action graph thing, I think that's very interesting. That's also something that Ola had a lot of interest in. From Bazel perspective, I think it's very hard to get that into Bazel. Because Bazel is very flexible in ways that make it difficult for it to work with an API. But if that could be made to work, that could be a significant performance win. It can also, it's one of the ways that you can reduce network round trips, right? So the remote execution system can start running actions without having to wait for the client to call back. If you have the action graph, if you have parts of the action graph. And that means you cut out round trips, you cut out uploads, you cut out downloads. You can reserve machines. You can reuse the same machine for like a sequence of actions. And then that may also help if you can keep like parts of the file system around. You don't have to throw away everything and start over from scratch. The other thing that Ed has worked on, which I also find very interesting, is like the local fuse file system. Now that's mostly independent of the remote execution API. And the way he implemented it, it doesn't need any changes to remote execution API at all. But there is a question, can we do better than what we have right now? What would that look like? I don't know.
One area of improvement that I would like to see is to improve the parts that are somewhat underspecified right now. So mainly execution environment. There's, like for example, build stream currently requires the input root essentially to be the root inside either some sandbox or at least some root environment. And base has completely different requirements. And it would be nice to see some more interoperability between clients and servers to at least be able to specify this properly inside the actions.
I do think that interoperability is probably the next real frontier for us. We have an API that we all mostly adhere to, but I don't know. Maybe I am the most guilty of not adhering to it. But I think if we can sort of start getting more and more on the same page, and I think Ulf has been kind of a recent driver of that with Enchflow and Bazel. I think that will benefit us all in the long run, and it's probably time, you know, that the ecosystem has matured to the point where that would have some real benefits. I don't know that V3 is necessary for that. I think V3 is a significant amount of work and still leaves us in the position of needing to support V2 for a substantial amount of time as well. So to the extent that we can make incremental changes or clarify the spec, and even if they're somewhat breaking changes, but we can kind of get everyone caught up, that may leave us in a better place.
There was a question that just came in that was about similar behaviors, essentially, where we get a compliance test suite. This is actually sort of what I was aiming for with the remote APIs tests. It turned into more of a does it all work? Does it, a smoke test associated with performing one build? And I think that honestly, taking all the time to meet all of the compliance specifications, or at least meeting all of the standard specifications that we've included so far in the API protobuf itself, and then accompanying documentation, I think that would probably take a pretty major effort, and would be something that would need to be that, in terms of prototyping, in terms of research for a V3, that would be a phenomenal thing to have first. And to see, for every specification that we've got, something out there that is at least hitting the API and testing that spec and proving that out.
So there is the remote API testing project, which was, I believe, created by CodeSync, and that is running some scenarios where it's different clients, like simple builds with different clients against different server implementations. And so that's going a little bit of the way there, but it's not really a complete test coverage for any part of the API. It's just whatever those client tools happen to be using, it kind of works most of the time. We've certainly found cases where we took open source projects that are running that can run against remote execution service, and we found that they have started to introduce certain idiosyncrasies that I think are against the spec, but I'm not entirely sure.
You can't prove anything else. That's cool. So I'll jump back to the other question. What are some of the biggest successes or pitfalls? What did we succeed at when we went from V1 to V2? And then what are we gonna take in terms of either strategies or what do we not want to let go? I mean, that's an open-ended idea. You can't let go of some things to have some backwards compatibility. But I suppose V3 could be a completely incompatible API. We could switch over to Philip and Jacob's insane bidirectional API that requests content from the client and there's no request or response, and you just fill up the remote, and when you're done, you keep going. Is there anything that we think absolutely has to keep going? Do we have to have a CAS? Do we have to have a separate action cache or a behavior that looks like that? Or could we put everything into one service and just be the call and response or send an action graph interface? And would that just take another 6 years to do?
Yeah, that's a very, very broad question. I think there are some concepts in the current API that are sort of universal, like the fact that you have an action, the fact that the action has environment variables and a command line and inputs. That sort of in my mind, that's sort of the minimum way, that's minimum information you need to describe how to run something remotely. There is one alternative for the inputs where you say we don't provide the inputs up front, but we sort of fetch them on demand. So if you start running the tool, and then as it's trying to read stuff from the file system, you ask the client, and that's something that Microsoft has been playing with and testing out. And we've had talks about that in the past, and unfortunately not this time, I think. But that's a very interesting approach, and that's also a direction that API could be going in. But still, at least you have the concept of files, you have the concept of command lines, the concept of environment variables. Going away from that seems very difficult to me. I mean, it's something where we want to be able to run existing compilers and existing tools, and they rely on these conventions. Now, apart from that, do we want a CAS? I think a CAS makes a lot of sense, right? A CAS is a way of deduplicating your inputs, so you only upload each file once, right, based on contents, and that makes a lot of sense in this context. And certainly you need a way, to upload and download files from the CAS. And so, I think a number of these concepts are really very solid and going to be appearing in pretty much any API that we can come up with. But there is certainly a lot around the edges where there's a question. Like Ed had a proposal for not so originally we said there is. You run an action, you get a file with standard output and a file with standard error. Now, the downside with that format is that, well, first of all, you have two files rather than one file, and then you don't know how these were interleaved, right? Maybe the first line was written to standard out, the second to standard error, the third to standard out, and so forth. And Ed had a proposal of using like a unified format of using JSON or protobuf or whatever. To store that in a single file. And I think that's very, very interesting, and maybe something that we'll go with, but I'm not sure that is, that would be considered universal.
So a couple other thoughts on the topic of CAS, since that seems to be a hot button issue. I think the CAS made a lot of sense it makes a lot of sense for this kind of system in general, because of the efficiency of it and the deduplication and the ability to reference files. I think we're also seeing an increasing amount of scrutiny on supply chain and supply chain attacks. And I think that the CAS provides some nice properties. It provides a choke point where you can really assert certain properties about your input files. And I think that as that gains importance, it gets even harder for me to see us moving away from a CAS. And in fact, I could see getting to a point in V3 where we decide that asserting certain properties around provenance or inputs or something is important enough that we need to include it in a build API rather than doing it via a side channel or in an implementation-specific mechanism. I don't know what that would look like, but I could see that being a direction that we take the API in.
So more protection, not less. I think the idea that, yeah, we've got low-level instruction level behaviors associated with storing stuff and retrieving stuff and maintaining that cache. They actually boil, in my mind, down to smaller behaviors like maintain a mapping that depends on its content, maintain a mapping that doesn't depend on its content, and start performing the execution. That to me is the one oddball out. But adding on to that and keeping those capacities through to a V3, I think, first of all, it would make debugging it way easier. Trying to encapsulate an implementation completely under the idea that we send a request from a server to retrieve content, and then wonder what's in the remote content side without having access to that would just be a nightmare anyway. We're getting more questions than we can possibly deal with, so I'm going to try and summarize. This sort of goes along with a point that I wanted to ask about. What are your thoughts about merging REAPI with the remote asset API? And what I think that really means is asset into REAPI. And I'll go right alongside that and say, what about the remote workers API? And when are we going to throw that away?
I mean, with regards to the remote asset API, I mean, the main question is there to essentially replace the action cache or not. I mean, as long as they are separate, it doesn't really matter to me whether a remote asset API is like part of the same repository or same versioning or not. But remote asset API could replace the action cache usage generalization, although the latency or number of round trips could be higher. So this is a potential downside. So
it's possible that this doesn't mean not having a service. It's possible that this just means throw it into the same proto world and proto namespace as the REAPI. Maybe that doesn't make too much of a difference to everybody. But I think that the REAPI doesn't include the asset API today. Maybe I'm wrong to think of it like that, but I know that the REAPI doesn't include the workers API, and yet it exists and lives alongside it. And a question is, are you compliant? Was I compliant before I implemented the remote asset function fetch? And I know that I'm still not compliant by the protobuf for not implementing the other 4 functions, but nobody else calls those, so I don't really know what we're doing there.
So I think the remote asset API is separate for good reasons. There were a lot of discussions around how to incorporate that. I do think there's potentially space for allowing asset IDs as an input to the execution API. So making asset IDs appear to digest, for instance. We've done some thought experiments around that, determined it was not worth the effort right now, but I could see a future world where the ability to reference, for instance, a Git commit ID directly in the REAPI might be really valuable and useful and save moving a lot of bytes around. I think it's a ton of work, because as soon as you do that, then you have to start thinking about, okay, it's not just the inputs. Maybe it also needs to start appearing in the outputs. Maybe it needs to start appearing in intermediate nodes in the Merkle tree. It really would kind of touch all the pieces of the REAPI. So I think that would be a V3 kind of thing, not an incremental evolution of V2. And it was hard for me to see the benefit of that when you could instead, use the asset API to create a quick mapping service between one ID and another, or something along those lines. As far as remote workers, since that was the other question that George raised, I think there's a lot of value in having a remote execution API that is shared and agreed upon by everyone. So all the implementations, all the clients and servers can speak the same API. I think that there are so many different and valid ways of building workers that I'm not sure that there's as much value. And I just don't see a world where, for instance, BuildGrid wants to, or somebody wants to set up a system with BuildGrid as the server, but their own, but a worker from a different system or something like that. I just don't think the interoperability possibilities are high. I'm open to being convinced. I know, George, it's something you've been advocating for years, but I'm unconvinced that the real world use case is there.
Oh, I wanted to be clear. I've never been advocating for the remote workers API. I've been advocating for throwing it away. Like, I seriously took a look at that thing. It is complicated as hell. And then I couldn't, or it's not complicated at all, and it just doesn't fit the particular mental model that I have for what my workers ought to be doing. And I'm missing something conceptually that it's supposed to map to, which I don't, that's great. But I wish, or I hope, that nobody's going to come to me with it being a published API under our repository and say, why don't you have this implemented? I really want to plug in my hardware in the loop worker that only speaks this, and I have a custom worker, and everything else works just fine with it. But make this bizarre thing work, and I actually expend engineering effort or more time trying to go back and understand that. I'm actually ambivalent. Like, it's not, love it or hate it. I agree with you. I haven't seen the desire for that interop of dropping in those workers.
So
maybe you should talk to Ed Bounton. He's been, when I talked to him the last time, which admittedly is a while ago, he was very vocal about supporting the workers API. He works at Bloomberg, and my understanding is they have a lot of different hardware and also a lot of very old hardware. And they wrote a worker client that basically assumes minimal amount of, like, it's written in, I think it's written in C, and it assumes minimal amount of operating system support, and so they can literally attach any kind of hardware to their remote execution system. We haven't seen a strong need for that, but it's possible that someone could come and say, well, if you had support for this really unusual Raspberry Pi hardware, we would pay you a lot of money. In which case we would say, yeah, let's do that. Yeah, I don't know. I think that Google open sourced it because they thought it might be useful, but not with the intent of sort of, well, maybe also with the intent of setting a standard, but not necessarily with the intent that everyone has to follow it. Stephen may be able to provide more insight there. I was not as close to that part of the team.
I think, George, you do raise a good point that we have several different APIs kind of crammed together in this remote APIs repository. And it's not really clear what the expectation is. Is any service implementing this required to implement all of the APIs? And that definitely was not our intention. I could certainly see, for instance, a remote execution system that implements the RE API, but its distribution model to workers is a push model. So there is no workers API. It's just, it grabs the tasks and pushes them down to somewhere else. So that seems like something we could maybe clean up to make it clear that these are intended to be independent. In some cases, it'll be the same service implementing them. In some cases, it'll be different. In some cases, you might only need one or two of the three APIs. 4 APIs, I guess, actually, because we also have the Logstream API, which is another piece of that puzzle. I think that would be a lovely piece to clean up and incorporate better into the remote execution API, whether in V3 or as an incremental evolution to V2. I know it's in some places there, but not in the most useful place, which is the action result that we might want to give back and let people stream back. So I think that is something we could clean up, is making clear what the expectation of the relationship between these APIs is.
As part of this, also make sure that the capabilities parts are really clear, which capabilities are for which service, and that was a huge mess in the beginning. Or
yeah, I think there was an earlier question about what are the big lessons learned. I think one lesson we've learned is that what we did with capabilities didn't really work. We either need to get rid of it and use semantic versioning properly for the various different services, or we need to split capabilities by the service or something. But it seems like it's not really fulfilling its original mission, although it's a great way to tell if you don't have a proper credential, because it's the first thing that any system calls. So if you see a failure there, you're probably not authenticated.
Well, the problem with that is Bazel makes that call very, very early in the startup, at which time it doesn't actually even have the console output properly set up. And so we've been trying to make sure that capabilities call never, ever, ever fails, to avoid users having like a really shitty user experience where the Bazel output looks like crap.
Yep, I've seen that a few times.
Is that a blocking call?
I don't know.
No, I don't think it's a blocking call.
Think it blocks, but I think it does fail your whole build right away.
Yes, it does.
So what we do is we wait on the capabilities call on the other side of that until they've transmitted some BEP that we're not really listening to, and ensure that the console output is there. We have to have a progress message before we send that response back. Okay, I'm going to jump over to another question. We've got about 15 more. I'm going to try and distill the one that I thought I liked.
I like this one here. Which is that the question is what are the big issues with V2 that we would want to address in V3? Or are there actually any? I think that sort of goes to the sort of a larger question. Is there anything major missing from the API? Are we just doing a V3 API that does the same thing, just differently? In which case, is that worth it? I don't know.
So I think George kind of touched on some of this earlier. I think we could do a V3 API that sort of removes the deprecated fields that we put there and cleans up some issues, gets us off of ByteStream, gives us a bit more flexibility around putting compression in things like the batch APIs, things like that. That seems like a lot of work for not very much payoff. And I'd rather do that via incremental evolution. I do think that there are the potential for some major evolutions, whether it's a bidirectional protocol or an action graph or something. But I also think that the action graph in particular, I could see just being a completely separate API. We've had multiple proposals. Some of them really are an incremental evolution. Some of them are much more radical, to the point where I'd say, yeah, this isn't really remote execution. This is remote action graph execution, and it could just be a completely separate thing. So I think we're all at the point where we feel like there are lots of warts that we'd like to clean up, because, hey, we're all infrastructure engineers and we want things to be smooth and shiny and work all the time and be clear how they work. But I also don't think we've found that motivating use case that would say, boy, this is really worth all the effort to get standardization, to do the prototyping, to implement this, to migrate all the clients, to maintain dual support for V2 and V3. That's a huge mountain to climb.
No, I think there's a clear sentiment that we're not there yet now. It's been 3 years. I think if we were identifying issues that were so severe in V2 that we couldn't live without a V3, that we would have just been at V3 already. I'm really looking, my agenda looks like find a way to identify when we get to remove some APIs that aren't being used, or that we change the structure in a way that no longer makes the previous version work, specifically just to identify a major version break. Not like trying to break users, but that, what would we do if we had the chance? And oftentimes it sounds like in our working group meetings and going over 2 years of data that we would do a lot, and then nobody moves and we're not really breaking anything, and maybe we can all accomplish our goals without having a new necessary implementation past the API. If I had to say anything, it would be, can we restructure the repo and clean up all of our specifications and add maybe some metrics or some other information about what we're doing, all of that without going to an incompatible version break.
Yeah, I think performance-wise, there are a lot of small things we could do to improve performance, and the reducing the number of round trip is one of the things. But the clients, the main clients, at least that I'm looking at, are so far away from using the existing API optimally that they're lower hanging fruit than changing the API. With that said, there is at least one major use case that I think the current API doesn't support at all. That is integration testing, where maybe I want to not just run a single action, but I actually want to run sort of a multi-part action where parts of it run on one machine, one type of machine, and the other part runs on a different type of machine. So it's something that I looked at very much this week, where we have some code that specifically works only on macOS, but we want to be able to trigger that from a Linux client, from a client that is not running on macOS very specifically. And so right now, doing that with the existing remote execution API isn't really supported.
Platform properties allow this. I mean, you can't do it in a single action to run on different machines, of course, but if you split it up in different actions, you can do that.
I think the question for me is how much of that, sure, I mean, you can come up with ways of doing that in the current protocol, but I think the experience might be significantly better if you can tell the remote execution system what you're doing, and the remote execution system can give you a little bit of support there. Right? One thing that can happen is the Mac pool is completely full, the Linux pool is empty. Now my action that I'm running is running on Linux, and it tries to run something on a Mac machine, but it can't get anything. And so every time I do that, it times up. Right? Not an ideal user experience. It would be better if I could tell the remote execution system, I need a Linux machine and a Mac machine, and please don't start running anything before you have both. Right? And if one of the pools is constantly overloaded, then maybe we'll have to defer that action or something else, or maybe it should have a higher priority, or there are a bunch of things that we could be thinking about in that space. Yeah, it's not super urgent from our perspective to do that, but it's certainly something there. I think the current API isn't doing, isn't immediately doing as much as it could.
Yeah.
Boy, if I had a bunch of people willing to pay me money to do that, I bet I would put that into the execution properties or the platform properties, and make it all non-standard and uninterpreted, where you can't prove anything.
I think, Wolf, you're absolutely right. The current API does not support that well. You're also right that you can kind of hack around that for a low-scale version of, let's throw this stuff in the properties and then just kind of hope that everything works, or have a clever enough scheduler to deal with it. But it's definitely not optimal right now, and I don't think that would scale to a system of any significant size or complexity. So that's certainly something we could look into. I don't know what an API like that, what an API for that would really look like. Although I wonder maybe about having a separate API that allows you to accumulate the various hardware that you need into some sort of unit, and then you can pass that in as the schedulable unit from the outside, something like that. So maybe it doesn't go in the RE API, maybe it's a side channel mechanism that allows you to do that.
Or maybe even combine it as part of the action graph API, essentially have parallel actions inside an action graph.
Now, my client that would run on, that would get scheduled on the Linux box would then talk to the local remote executor and request his operation elsewhere. Because God, if you expect those things to work in tandem, I would fear what would happen when the Mac side dies and I have to reschedule and hope. Yeah, not having units would scare me as an API implementation.
Yeah, another thing there is also security. Ideally, you want the remote execution system to set it up so that these two boxes can talk to each other, but not anyone else. To avoid, right, like, you know, if there are multiple actions like that in the system at the same time, you don't want them to affect each other in sort of weird ways and cause failures and that kind of stuff.
Yeah, that's an interesting point as well, that I think we on RBE have enough trouble dealing with scheduling nuances and, you know, different types of machines and things like that. And I know that we run on a much simpler setup hardware-wise than most people doing RE. I do wonder if the API could help in some way, but again, I don't know what that is. So maybe that's a fruitful area to explore for a V3. Could be motivating. I think that there's part of the problem is how do you go back and specify all of this in the client as well, that you have not just the API layer, but, you know, what sort of Starlark do you need to provide to Bazel, or what do you need to provide to your other clients that make this a reasonable thing for users to configure on their own?
Yeah, and to make things more interesting in that area, Bazel today doesn't support building for multiple platforms in a single invocation somewhat. But yeah, building, you know, multiple, defining a test in Bazel that says I need this binary built for macOS and this binary built for Windows and this binary built for Linux, all three in the test in different actions. It currently is not really my idea of a good time. I'm hoping that Bazel will get there, but it's not easy to do. It's not even easy to reason about what that would mean.
I want to say real quickly that while we're not addressing all the questions here, I will happily, probably tomorrow, because I've got some stuff right after this. I will happily participate in any water cooler discussions or breakouts. That if anybody wants these answered, I will put all the answers for those in there, or at least as much as I know the answers, and want to offer that up. I like the last one. Any ideas for V3 that will make it easier to run geo-distributed remote workers? We hurt on latency a lot. You're correct, Ulf, that crossing the channel is troublesome in many ways. And I don't even know, like, I was essentially unable to handle much more than 10 milliseconds of latency per request. If I did that, my days were usually spent explaining why the builds were backed up to such an extent that we wouldn't resolve for another 8 hours or 10 hours without spinning up hardware that was literally closer. You can't beat latency with a stick or with parallelism. You it beats you.
Yeah, we have some geo-distributed clusters. Well, at least one. Let's put it like that. And the use case, in this use case, it's so important that these are geo-distributed that we're willing to pay the latency price to make it work. The advantage of, so clients, most clients, I believe, today can only talk to a single cluster. And so if you need to do builds that work across multiple architectures, where maybe you have some ARM in there, or you may need a like special hardware, then it makes sense to have a single distributed cluster, right? You can cross compile from, I think Banu talked about that today. You can cross compile from Linux to ARM, and then you can run it on specialized ARM hardware that you have in your office. And so just the fact that you have it in the single cluster is more important than the latency. And there can still be significant wins despite the high latency. But yeah, we've talked about geo-distributed pools when we designed the API. One of the things that I think is sort of troublesome is that we only have a single CAS. We only have a single unified CAS. It's great. It makes things a lot easier. But having a single unified CAS means that everyone has to be able to talk to a single central location, and in the worst case has to bite the bullet and pay the latency price to talk to that location. The other single point of entry for the cluster is, I think, the schedulers, which is also the API is designed to have a single entry point for all calls, and a single unified CAS system. And so those two things together make it hard to do really, really super efficient things in that space. But I mean, what would they look like? That's not clear either. How do you find the right CAS for the file? And then you put that logic into the client. How do you put that logic into the client?
Yeah, there's a so we haven't touched builds without the bytes, and that's technically because it does and doesn't matter, and it's leveraging the API. First of all, I more or less am pledging this year to go into Bazel and fix action rewinding and make that work. I am done trying to make a perfect CAS, and I will find ways to do things like deal with the fact that the previous CAS changed, didn't exist, got screwed around with. And this is more of like, I'm going to write this for Bazel, and nobody else really should be doing this going forward. But Bazel is relying upon features that I think are driving decisions associated with the API, and certainly driving people's choice to as to how they implement their CAS and how they implement their action cache. Yes, I'm breaking the standard by interpreting something associated with the build request ID as either when you make your action request, ask the CAS about whether it has the blobs or not. And I'm doing that because of this rewinding nonsense. And the where was I going with this? So I'm going to go fix that. And there was something else associated with what we were talking about that I can't remember.
I'm very much looking forward to that. I've been very tempted several times to go fix it myself, but time. What is time?
I wanted to chime in too on the idea of geo-distributed workers. A couple other thoughts. There are certainly very legitimate reasons to want to run geo-distributed workers behind a single RE system. And as already pointed out, even it doesn't take much distribution to spike your latency to the point where it causes real problems once you're moving out of, a single co-located cloud or something. There are also, I think, maybe not as good reasons to do it. A lot of people might be wanting to look at geo-distributed workers for reliability reasons, and what happens if your data center in Europe goes down and you want to fall back on something in North America or things like that. I think that is better handled at a higher level. So you run 2 RE systems, or you run an RE system in each region that you want. And depending on how you want to set things up, maybe it can pull from the CAS or the action cache across a region. It is somewhat inefficient that you end up running maybe more workers than you need to, or executing things multiple times once in each region. But I think you end up with a better fallback mechanism where you're redirecting at the build level rather than paying unpredictable latency costs at the action level. So just something to think about for whoever was asking that question, that I think you're going to increasingly want to start looking further up your stack in terms of optimizations and reliability.
Here's a cool question. Could V2 currently also support peer-to-peer scenarios to leverage spare desktop machines without having dedicated schedulers and worker machines? We thought about that when we started coding, because we thought, this seems like it might be a very cool feature to just have peer-to-peer remote execution. And I think, well, the way that we would do it is basically run something on your machine that effectively terminates the V2 API, and then behind the scenes do a distributed peer-to-peer protocol that is completely different and has nothing to do with the remote execution API.
No, the workers API is what you got to use there.
The client doesn't really care, right? As long as it has something that it can talk to, and using this API for that, and then going peer-to-peer behind the covers seems like it's perfectly feasible. I mean, there's some caveats, but there are always caveats.
So yeah, I don't know as much about strict peer-to-peer, but I think the intent of the question is basically, if you have a bunch of workstations sitting on people's desks, could those be plugged into your worker farm? And I think V2 would absolutely support that. You have to figure out how to do isolation, whether that's using something like Docker or using a cheroot, but making sure that your actions execute in the same environment, regardless of machine. And there are the previously discussed latency concerns. So when somebody ties in their desktop from China, is that going to slow down everybody's build? But I think the protocol itself would fundamentally support it. And I don't think you necessarily have to go a full P2P sort of behind the scenes in terms of maybe proxying CAS inputs or things like that. It depends on what your network setup is.
Yeah, I'm having flashbacks to really bad memories with ice cream and not dist CC so much, but other weirdness. Like you could do it; it could be really cool. But the idea of using or of finding storage behind those machines, like that's what kills me on all of this is, and this is more an implementation question. Can you do it? Yes. Should you? Probably not. Or rather, are you going to increase your pain?
It is very appealing, right? If you have an office with, 100 people and you have 100 desktops in your office, why can't you use that CPU that's sitting around there? But
I say it's tainted. Like, as much as I agree with you. The homogeneity of machines is it's problematic enough to maintain. It's just I don't even want to go down the rabbit hole. I mean, other people more than welcome, but I'm glad I'm not trying to do it, because I saw what it looked like.
Yeah, I also have memories of engineers like trying to run local benchmarks, and then something else is running on their machine, and they're very, very upset about that.
I also shudder to think of the security implications, and what happens. Like, does your build team get the ability to just unilaterally restart somebody's workstation because it's gone rogue and it started pulling down and trashing.
We need the release out today. I gotta kick your machine over.
There's lots of fun stuff that can happen. I do think that one of the promises of remote execution is to reduce the reliance on local hardware. So the idea that you can run wimpy machines as your developer workstations and all the heavy lifting is done by the cloud is great. It works sometimes. You can look at Google and look at what they provide the typical developer here and how many cloud resources they deploy, and that'll tell you how well it really works at scale. But for a lot of projects, it does work pretty well that you can downsize your local resources.
Yeah,
awesome.
All right. I think we have to wrap up. It's almost 5 past. So this was fun. Thanks everyone for participating. And if you have any more questions, hit any of us up anytime. Well, at least me and George already offered, so I'll just extend that to Steve and Jörg, if you don't mind.
Jörg is great.
I will put in a plug too for the monthly Remote APIs sync that we have, where we talk about a lot of these issues. If you just go to that Remote APIs GitHub repo, it has a link to the right email group to join, and you'll get an invitation if you'd ever like to show up and ask a question.
Yeah, and I'll plug very quickly the Build Team World Slack. That Slack is more or less where I've talked about everything related to Remote API for the last 4 years. I can't think of a bigger discussion that I've had outside of conferences or talking to these 4 guys that has more concerned the API's definition itself. I'm always happy to explain stuff, and you can come in at any level. New clients and new novel uses of this, I think, are we're just brimming at. I see people chasing down BEP and BES, and I think that one thing that would be really beneficial would be better tooling, better logging, better filtering, better indexing, and that's should be able to cross all the divides in terms of implementations, whether it's Build Farm, Build Barn, EngFlow, RBE, and then the clients themselves doesn't really matter either. We're just talking this protocol. We're just talking this behavior, and I think it would kick ass to have a nice set of tools and leading down the way of getting to better compliance and then better utilization of what we're doing. So for that, my 1 minute over. Thank you guys very much for showing up. I really appreciate this, and look forward to seeing everybody at the next monthly.
Thanks, everyone.